Amanda, we got to.
Oh, okay, gotta go. So, oh, could someone let?
Just saying.
Honest.
I'm excited about that. I didn't turn in some of the other homework, so I get some understandings.
Okay, lots of quick announcements. I emailed out a bunch of these, but I want to say them again just in case people are having email problems or whatever. One of them is when you go to the turn-in problems, very few people are rushing ahead this much, but David was, so thank you. He's not here, but anyway, for finding this. In the Mad Science, when you go down to measurement, your page we printed at the beginning of the term says hours for the first measurement problem. 2 years is how many, it should be minutes. So I fixed it online, but if you're doing the right thing and working from your green paper before staring at a screen, then fix yours so it says minutes instead of hours right there. Another announcement, I handed back most of your quizzes from last Friday since no one was getting back to me saying, here's a revision. Someone get the door? Then I just passed them all back and told you if they were good or not. So there we go. There's 2 people that didn't have code names until I did the grading of the Friday pop quizzes from last week. So I sent you out an email not very many minutes ago saying, I've just given you a code name. Give me a different one if you don't like it. But that also means you haven't been turning in homework. And just a heads up that the achievements for things, turning in half the homework on time is still quite possible. So if you're someone that hasn't been turning in homework, then we have 2 things due on Friday. And if you get them in, then you're only missing one. The rounding one is the only one that's been due before Friday of this week. So this is still a very doable star for people. Don't feel like you have to give up just because you haven't done all the homework on time. Okay, other announcement. If you are going for a B or a C, I've successfully sorted out that now there's the no calculator part of the final and the actual final on the day of the final. This will do during week 10 sometime.
What week are we in?
We're on 4.
Okay, good.
So if you are somebody that likes to practice things ahead of time, you can now take as many random versions of the no calculator test and the final as you want. It is ready to go. I might have to put one more problem on the final. If I don't, then it's just going to be exactly like that. When you load them, the problems change. So not only are the numbers slightly different each time, but sometimes it says find the prime factorization for number 3, and sometimes it says find all the factors.
The answer key on there?
The answer key is on the bottom and it always updates. So that's a good point though. A unique point is that if you are practicing this at home and you want to print it, because it's nicer to work from paper, print the answer key. Because if you close the browser window, then next time you open it, it's going to be different.
It wouldn't let me print the answer key in the library, so I just screenshotted it.
Oh, it should. You just click on show answers and then it's all there and you hit print. I've never heard of anyone having a problem with that, but that is odd. Okay. Well, bug them in the library if they're not doing it. So if you go to tests, here they are. Here's the no calculator test and the final right up at the top. And I think that was all for announcements. Okay, any other questions sort of class-wise about where we are or what's expected of you? Oh, there was one other one. That to earn a letter grade, you have to turn in so many homework stars and things like that. And as my email pointed out, I am not going to automate counting how many homework stars you have. The website certainly could.
So we have to do this part?
But when you notice that you have 8 or 10 or whatever, then let me know. Tell me in class, send me an email. But we should celebrate for a brief moment together that you're checking something off and not just have it happen automatically without anyone noticing.
Oh.
So there we go. Yeah, so I guess the first one is 5 homework stars, and there's quite a few people that have 5 homework stars already. So if you need that star, then go ahead and let me know.
I think.
Whoops, wrong one. Topics.
Oh, yeah, I did.
Okay.
The final is, we can have calculators.
The final, on the day of the final, you'll have a calculator. Because, well, the whole point was to sort out the no calculator problems and do them earlier. So you don't have to worry about them on the day of the final.
Do you have an online? I got 5.
Oh, but I was going to ask people about that. Back to announcements. So if you look at the achievements now, I haven't put that you have to do the no calculator test to earn a C in the class, because I can't imagine anyone would do 65% on the actual final if they couldn't do those anyway. But I could put that in the list of things. It wouldn't be hard to do. Should we make everyone do the no calculator thing, even if you're only aiming for a C?
I
I don't think so. I mean, it would be just one more thing for us to worry about.
Well, it's going to happen during class time anyway, so it's not like you're not going to be here.
No.
65% isn't that high a goal. I'll keep thinking about it.
Not having it in the
Whatever
requirement.
doesn't hinder our grade at least.
It might be that the math 60 people will say you don't need as much fraction stuff on the actual final if you require it of the people to pass the class with the no calculator one. Does that make sense? Because they want you to be able to play with fractions when you get to math 60. Okay. Not sure about that yet. Math 60, by the way, is easier than 20. Math 20 has a much higher rate of people not completing it or failing than 60. Because math 20 is to this absurd salad bar of too many different things you have to learn, and they don't all fit together. They're just like, you have to keep track. It's like a juggling exercise. Whereas math 60 and 65, everything builds off the previous thing nicely. So you don't have this bizarre thing where you get to week 10 and you can't remember anything from the first 3 weeks because you haven't used it since then. So, and don't be afraid of 60. People do better on 60 than 20.
That's something good.
Okay, homework questions. We've done everything with fractions. We've done nothing with percents. So don't ask me percent questions yet. We haven't done them yet if you're rushing ahead. But anything with fractions, we should do homework questions.
So you want us to, once we get 5 homework assignments, to email you to tell you that?
Yes, or tell me during class or something. So.
I got 5 homework assignments. I said I got 5 homework.
Okay, I will put Sheila down. Yay for Sheila.
So there's Lexi.
Lexi too.
Lexi, yeah. What?
I'm finally learning names. This class was just ruthless with the number of nicknames. The number of people that send me an email and the email address has a name and then the name I'm supposed to call you is something different. Oh, come on. And you don't even say, hi, this is unique. It's just, no, it's just, I have to remember that. It's like, you have 2 code names, not 1. Anyway. Okay, homework questions on fractions. Things from the book, things from the turn-in problems. No, we could just go on, but how about the terms part in the fraction section? Should we do another of those long, break things up into terms? Yes? Okay. So I will jump to the final and say, where is it? Maybe it's in the no calculator one. Yes. Okay, and this is 3 cubed.
Oh, we're doing it.
Oh, come on. No.
This is what we did yesterday, right?
Yes, this is what we did at the end
Alright. I didn't do any homework.
yesterday. So remember, as I am writing this, when I get to a plus or minus that's not in parentheses, I'm going to give it lots of elbow room. So 4 times 5 plus 18 times 5 plus 12 minus 9 plus 81 divided by 3 cubed times 2 to the 4th. So we had a break in terms here, and here, and here. So I gave those three plus and minuses lots of wiggle room around the edge to help my eyes. Even for the plus in parentheses, I spaced it out a little bit to help my eyeballs see that the 18 times 5 comes before the plus 5. That just looks better. Okay, so these will just continue down. Maybe 2 rows will be enough. And the whole point of the terms is that everything that's one term is independent. I don't have to look beyond that green barrier there. So for the first term, I'm starting with what's in parentheses. So 5 18s, well, 5 20s would be 100, but that's 2 times 5 too much, so that's going to be 90. And then 5 plus that would be 95. 4 95s, well, that's almost 400, but that's 4 5s too many. So that's going to be 380. Did I do all that right? Somebody with a calculator check. 12. 12 is just 12. Terms can be one number. 9 is just 9. Okay, what, was that really 3 cubed? It was, okay. So what's 3 times 3 times 3? 3 times 3 is 9.
27.
And then another times 9 is 20, whoops, go back. So that's 27. And what's 2 to the 4th? So 2 times 2 is 4, times another 2 is 8, times another 2 is 16. Everyone okay with those exponents?
Yeah.
Okay, I have only multiplication and division right here. So I'm going to just go left to right. What's 81 divided by 27? There's 3 27s in 81. Let's do another row. And 3 16s, well, that's 30, and another 18, so 48. Not sure why that jumped down. Why don't I make this 2 steps as long as I made another row? That might help the people at home. Okay, so I have 380 plus 12 minus 9 is going to wind up being 3 bigger, so I'm at 383. I'm going to take away 48. Well, if I take away 8, then I get 375 and take, oh, I'm adding 8, I'm sorry, adding 8. So 383 plus 48 would be 20, would get me to 403. And another 28 would get me to 31.
431.
431, yeah. If I was actually doing this problem on the no calculator test, I would be writing a lot in the margin, not trusting my mental math.
Oh, this is no calculator problem?
Yeah, this will be a no calculator problem. But you could do 18 times 5 on paper. That's not
Oh,
too
yeah.
bad. Right? You could do 81 divided by 27 if you had to. It's never going to work out to have decimals or funky things. It's always going to have the math be slightly friendly. Okay, questions about this one? Should we do it, get another one? Yes, yes, okay. Let's do one from the book, just for variety's sake. So section 4.4, page 245. Somebody pick one of those.
Oh, my looks different.
Your book is different? Your book shouldn't be different. Section 4. Oh, we always have to turn the page.
Just turn it.
So 55, 57.
Alright. Just the page or so off.
Which one should we do? Let me just grab your book.
Alright.
Oh. Now the book doesn't politely give you friendly numbers. So this one we're not going to do with no calculator.
Doesn't look fine.
Okay, and let's do another one before I give her. Okay. Oh, okay. Those look like good ones to do. Okay, so how many terms do we have on the screen?
2.
2, 3. Who thinks 2? Who thinks 3?
Now you have a second guess.
So which are the plus and minuses outside parentheses? There's that one
So,
and that one. So there's 3 things. And so the first term is 2.48 divided by something. 1 minus 0.544, so that's going to be 0.496. Make sure I'm doing my mental math. The other 2 terms are just numbers. So where is that 11? Is that 11 times 2 or 11.2? 11 times 2. Okay, so that's 22. What am I doing here? I don't know. So the second term was just a number. The third was multiplying. So there we go. We're not quite done simplifying the first one. We have 2.48 divided by that. So 5. On the test, you wouldn't be given something weird like this. That would be hard to do. Okay, if I add 24.3 and then I take away 22, overall I'm adding 2.3. So we're going to have 5 plus 2.3 would be 7.3. Since we have fancy calculators that can do long things, let's just double check this. has the answer.
It is.
Yep. Everyone okay with all three of the terms? Okay, how many terms do we have here?
One.
One. We have a minus that's not in parentheses. So 2 terms.
Oh.
So the first term, 12 squared divided by something. So 12 times 12 is 144. Twelve divided by 2.4 is 5. And then 144 divided by 5, ugly number. So that's one of our terms. The other term, do we need the brackets, by the way? That's already its own thing, right? So the brackets there are just extra, right? So first we're doing the small parentheses things. 2 minus 1.6 is 0.4. So 28.8 divided by minus 0.5 will be 28.3. Questions on that one? Okay. Is it working that once we have the terms, then no one term looks huge and unmanageable anymore? That's the idea. Okay. So moving on. When we are talking about using percents, this is a new thing, because before we just talked about converting numbers into or out of percent format. We haven't actually done anything with percents yet. So the first thing we're going to do is use percents with the word of. The word of in a word problem tells us we multiply. And that makes sense. Multiplying is making copies. So when I say to someone shopping, yes, I'd like to buy 5 of these, and I'm saying I want to buy 5 copies of those. Right? So if you have tickets to a park cost $25, the family buys 5 of them, what's the total cost? $125, right? You're multiplying. It makes sense that of means multiplying. If it takes 7 minutes to grade a test, and there's 30 tests to grade, then how long will the grading happen?
210 minutes.
210 minutes, right? So, actually there's no of in that one, but there should be right now. So there we go. If we have fractions, we use the word of, and it flows quite naturally. In a sports program of 350 children, 3/7 of the children are boys. So we can multiply. If I did 350 times 3/7, that's a good review. What's my first step?
21.
Yeah, let's make this over 1. I could multiply across, but I don't like that giant number that's going to come out. Cancel, yeah, divide by 7, divide by 7. If you want to skip the 150 over 1, that's fine. was that one. Or Rihanna eats 5/8 of a pizza, her daughter eats half, then how much did this person? Okay. So the other time that of really often means multiply is percentages. So what is 40% of 200? Let me make this a little bigger. I'll take the 40%. Use my riplop. Am I going into or out of percent? Out of percent, right? I'm trying to get rid of that percent symbol. So left out of percent. So I will get 8 and then scoot over and 80. Questions on that one? You're welcome to use a calculator if you can't do 0.4 times 200 in your head.
Yeah. Wow.
How about 60% of 200? We'll change the of to multiply. We're again going out of percent. And we get an answer. Everyone happy staring at these two? This is why one of the things we talked about for writing, we don't want your decimal point dots and your multiplying dots be confusing if you're using dots for multiplying. Okay, onward. If we have a labeled amount, nothing changes. If we have 40% of 50 hours, we'll change the of to a multiply. We still want to get out of percent. The only slightly confusing case is if both numbers have a percent symbol. And you want your answer to be a percentage, right? What's a certain amount of this percentage? You want so-and-so percentage. So the second percentage is actually a label, just like hours or oranges or elephants or whatever your word problem is. So I will riplop the first one because that's this pattern you've been seeing. And the second one I will just keep around like a label because that works. Okay, question or stretching?
You keep the second.
Stretching, okay.
So you keep the
Yeah,
second.
keep the second one around, just like hours or whatever your word label is. You could even just rewrite it with the word percent, if that makes you feel better to have a word right here instead of a symbol. So we're putting two things together. One is the of means multiply, because you've been doing that for years, right? We had no problems at all doing these earlier problems without percentages. And then the other part we're putting together is when you have a percent, then to multiply it, you need to make it a decimal. And so you use riplop. As a heads up, calculators will often these days have a key that says percent on them. So don't use that. Right? It does different things based on which type of problem you're doing. We'll see in the next section, the justice section, there's 3 different categories of percent problems, and it does a different thing for each of them. And it is hard to figure out how to use. Since RipLop is so easy, just scooting your decimal point twice, it's much easier to always use RipLop and put decimals in your calculator than try and figure out how the silly percent key actually works. So. Okay, it gets better. So you can impress your friends with the switcheroo trick. When you're multiplying 2 numbers, it doesn't matter which order, right? 2 times 3 and 3 times 2 are the same. Percent just means divide by 100 when you're done. So the switcheroo trick means that you can RipLop either number if you're doing this kind of thing. So if someone asks you, what is 4% of 50? You could do what is 0.04 times 50. But that seems a little harder to do in your head. Not impressive at the cocktail party. But if you switch it, then you could say, what is 50% of 4? And that's going to be the same problem. So what's 50% of 4? 50% is just half. So half of 4 is 2. Ta-da! Now everyone thinks you're amazing at math. How about this one? What's 24% of 5? The awkward way to do it, nothing wrong if you have a calculator, but you could say, as we've been doing, what is 0.24 times 25 and get some answer, but I can't do that in my head. So the clever thing to do is say, what is 25% of 24, switching which one has the percent on it. So what's 25% of something? A quarter. So 1/4 of 24, 6. Ta-da! Right. Do you have to use the switcheroo trick? No, it's just a way to show off. Maybe save time. Because we have phones, we have calculators. 0.24 times 25 works also. Should we do another one? Okay, I see people writing. I'll wait a moment. Come on, scroll down. There we go. So the normal way to do the next one would be, what is 8% of 900? So use our RipLop. What's 0.08 times 900? And maybe you can't do that one in your head. You could take out your calculator and do that, no problem. If you switch it around, you could say, what is 900% of $8? So 900% is just 9 times it, right? Because each 100 is a copy of it. So this would just be 9 times $8. And that's something we can all do in our heads. So totally optional, nothing wrong with this. But if you want to show off, then there's a trick. Okay, your turn to do some. So, as you can tell from the bottom of the screen, a case to use this a lot is when you're tipping at restaurants. Traditionally, I don't want to, in a math class, have an argument about what's actually the right amount to tip people at restaurants. But traditionally, what you'll see in math textbooks is you tip by 10 or 15 or 20%. 10% of a value has a shortcut. You're going to move one place to the left, because all you're doing is 0.1 times the number. And 0.1, remember, is just one squeeze. To find 20% of a number, well, that would be 10% twice. So you would scoot once to the left and then double it. To find 5%, you would scoot 1 point to the left and then take half of that. Or to find 15%, you would do these two and then add them together. 10 and 5 is 15. So as an example, let's say that we spent 22 bucks. So what would 10% of that be?
$2.02
Not 2 cents,
or 20.
20 cents, right? Everyone see why? We just scoot the decimal point once. And we have to write another 0 on it because that's how we write cents. Okay, so twice that, $4.40. Half of that, $1.10. Or I would take these together and do $3.30. So again, a chance to show off. Could you take out your calculator and do 0.15 times 22? Sure. The reason tipping is a good application is that estimating is great. If this was $22 and whatever, 13 cents, that would make the math a little harder. But we can say, yeah, we're just going to tip as if it was 22. And then we can use nice whole numbers. Maybe you're a good tipper, and if it came out to be 330, you would do 350 anyway. Okay, so try 52 and 53 and 54. Check with your neighbor, and I'll do them on the board in a moment. Is that big enough, or should I go back to the other screen? It looks bigger there. Can I fit both the shortcuts and the, no, not really. Do you need the shortcuts on the screen also? Yes. Shrink, shrink, shrink. There we go. Stick that in those. Okay. I know what I should do.
Bless you.
People waiting for me to do the first one before being brave and doing the others. So we'll start with 10% of 25. So we'll scoot the decimal point once. Yeah.
Yeah, but I did.
Oh. Everyone get 5 for the first one?
Mhm.
Are you ready for me to go on, or do you need more time for 52?
I got it.
Okay, 10% of $20. The shortcut was to scoot once. So that's going to be $2. Half that. Is $1. And then put them together. So we get $3. Everyone okay with 53?
Yep. I'm gonna-
Okay, for 54, what's the 10% going to be?
$3.
$3. And what's the 5% going to be? 150. So we're going to wind up with 450. Everyone happy with all those? I should put my answer in the box. So this comment at the bottom is important. The word of doesn't actually have to appear in the problem. Just the fact that you could rephrase it to have the word of, what is 15% of 30, means that it's multiplying. The English language isn't so restrictive that we have to use the word of, but if it makes sense to do so, you're multiplying. Let's do these just out loud. 3980, I don't want to have to worry about all of those decimal points. Let's just round it to 40. Okay? So 10% of 40 would be $4. Half of that is $2 more, so $6. This one, oh, lots of decimals, right? So let's just make it 24. Scoot the decimal once, $2.40, double it, so $4.80. Maybe you're tipping for $5 anyway. Any more tipping questions? Is this a good one so far?
There's a tip calculator.
There's a tip calculator on your phone. Again, the shortcuts, you don't have to do it this way. You could do 0.15 times 39.80 and come out with an answer. This is mostly to show off with your friends at restaurants and cocktail parties. Because why else are you in a math class? Another common application is when you're finding discounts. A retail item goes on sale and we are given the percentage of the discount. So a book costs 12 bucks, it's on sale for 20% off. I have the coupon in my hand, I have the book with the price tag, so when I actually get to the cash register, what are they going to charge me? I could do 20% of 12 and make that 0.2 times 12. Or I could use my shortcut we just had. Well, 10% of 12 will be $1.20, 1 decimal point scoop. And 20% would be 2 1/20s, so 240. Address is normally $60, it's on sale for 30% off. So how much is the actual reduction? This isn't the sale price, by the way, right? This
No,
is,
you
this is
might
the
not
amount
have
That's
that
just how much you subtract.
back, right?
Yeah,
I actually
just
wanted
subtract
to have to
it.
subtract it away. So what's my coupon actually worth is what we're doing. So
Yeah.
what's the coupon actually worth for the dress? Well, what's 10% of 60? 6, just 1 decimal point scoop, right? So 30% would be 3 10s, so 18.
Mhm.
So my coupon is worth 18 bucks if I want to spend it on that dress. I have a jacket that normally costs $80. It's on sale for 60% off. If I use my coupon there, what's it worth for me?
40.
So yes, 10% screwed at once would be $8. 6 eighths would be 48. So I could save 48 bucks on that jacket if I wanted to. And again, we could use the word of. What is 60% of 80? Just because the word of wasn't in the problem doesn't mean it's not multiplying. If we could rephrase it with the word of, we're good to go. Do you want me to write more on the board for 58 and 59? Yes, okay.
This one. I went there. Are these gonna be calculator problems on the test?
Yes. Okay, is that good for 58? Everyone who wants me to write something is happy, or should I explain it? Oh, come on, draw you. There we go. That look prettier. No, I'm just gonna go back to here. Okay, everyone happy? Not more? You're good. Okay. Okay, heads up. All of these percent of problems told us a percent, right? The problem gave you the percent of the tip, the percent of the discount. There is a way to write an English sentence that uses the words percent of, but you're asking for the percent instead of being given the percent. For example, in a tank of 10 fish, 8 are guppies, what percent of the fish are guppies? You have this one that's asking for the percent, it's not giving it to you. So that's not what we're doing. We have no tools to do this kind of problem yet. So we'll get to them later. But just in case, and later this week, you happen to cross this kind of problem in the real world, that's not what we just did. We'll get to those later. Okay. We have time for this? Yeah. So our first step in working towards more complicated things is a certain type of when we have to find the percentage, and it's a percent change. So something used to cost this amount, it's on sale for 15 cents off. What's the percent of that decrease? This is how we like it, because the amount of change is given to us right there on the page. Sometimes the problem tries to trick us, and they don't say what the amount of the discount is. Instead, they tell us the new price. So that makes us have another step. So what's the amount of the discount for problem 61? Yeah, so that's a 20-cent decrease. So we have to find the decrease first with subtraction before we can go on. Everyone see the two categories of problems? We want to take an amount of decrease and change it into a percent of decrease. But we need the amount of decrease first. So if they hide it, we do our subtraction to uncover it, and then we can go on. Our formula we'll use before we actually do these is percent change is change divided by original. So for 60, how much is the change?
$0.60.
No, that's the new price.
How much is?
How much is the change in problem 60? Don't make it too hard.
Oops.
15 cents, yeah. And what was the original? 75. So 15 divided by 75 gives me 0.2. It asked for a percent. So I need to rip lop. All day long we've been rip lopping with the lop side of things. Now we're going into percent, so we have to go on the rip side of things. And this isn't surprising, because before they gave us a percent and they wanted a number, so we had to move away from percent world. Now they're giving us only numbers and they want a percent, so we'll be moving into percent world. let's do the next one and then I can go back and forth between the slides if you need more time. So here was the one where, what was the change? We had to do some subtraction.
Did you do this?
So our change was 20 cents, which is the original, the 80 or the 60? The 80. This is the only way to mess these up, is if you look at the wrong price and call it the original, because you're not reading it carefully.
Okay, so you don't.
So sometimes prices go up, sometimes prices go down. You always want the original price here. It's not always the bigger, it's not always the smaller, whatever the original is. Okay, anyone want the previous slide? That was that one. So this was the easy case because they just gave us the discount amount. We didn't have to do any subtraction. This was the harder case because they didn't give us the discount explicitly. We had to think a moment to find it. Ready to try some yourself before I write them on the board right away? Okay, let's just do that one. The value of a house goes from 150,000 to 170,000. What's the percent of the increase? Okay, what did people get for their change?
$20,000.
20,000. And which was the original?
170,000. Oh,
150.
Yeah.
That's it.
Okay.
Okay, when talking about housing change prices, are we going to care about the fact it's 13.3333%? No, so we'll just round it. We know the decimals really repeat, but 13% is close enough. Questions on that one? This is putting some of you to sleep. I am sorry. So we already saw one issue. Does it give us the change or do we have to subtract? And some people notice this thing with the coupons, that does the problem ask for the amount of the change or does it ask for the new amount? Maybe we care about what the sale price is, not just how much the coupon saves us. So for 63, if we put $200 in a money market account and we earned 3%, how much would we earn? What's 3% of 200? Six, yeah. Remember the switcheroo trick. What's 200% of 3? That would be twice 3, so 6. So for this one, we would get 6, whichever way you do it. Or the same problem could ask, what's your account worth at the end of the year? Then you would have to say, well, the $200 hasn't gone away, so we're going to do 206. So same math, it's just that the problem is asking you for a different kind of thing. So that's why these are hard. It's not like change divided by original is a difficult formula. You've been dividing for a long time. But there's 4 things to keep track of. So fortunately, I make a cute little picture. Does the problem ask for the percent or does it ask for the number? It has to give you one and ask for the other. If it asks for the percent, did it show or hide what the change was as a number? If it asks for the number, when you get that, are you done? Or do you have to combine it back with the original? So this is what makes these tricky. The math is not bad. Just you have to be on your toes.
Can I go back really quickly?
Sure.
You're 75 or 75 cents for sale for 15 cents, and then your amount of the discount you said was 20%. Is that correct? No,
Which one?
it
For
was
here?
60 cents off. You said it was
For here, and it's 15 cents off.
right. It's on sale for 15 cents.
No, it's on sale for 15 cents off.
Oh, I didn't see the off part. Okay, I'm so
Okay.
sorry.
That's okay.
I'm sorry.
It's a lot of stuff on the screen. Okay, I don't think we want to go on from here. Let's just do some more. More random problems. Okay, so I'll go to my random problems because I don't have a textbook with me. Round to the nearest dollar, let's estimate a 30% tip on a meal that costs $35.94. So, yes, as Sheila says, we're going to say this is close enough to 36, especially rounding up on tipping makes me feel good instead of rounding down. So 30% of 36, what was the 10% shortcut?
So
3.6.
3.6, right? For 30%, so 3 of these. So 3.6, 7.2, 10.8. That would be sort of the shortcutty way to do this. Or you could say, oh, shortcut's not so good. I'm just going to go 0.3 times 36. And get the same thing. Everyone happy with that one?
Yeah.
Okay, somebody loses weight and they go from 166 to 156. So what's the percent of the decrease? So percent change. It's change divided by original. What's my change going to be?
10.
10. Everyone see where the 10 came from? And which is the original?
166.
Yeah. So I'm getting about 0.06. I'm not done. What's my last step?
Change percent.
Yeah, change it to percent. It asked for a percent, so I have to do what my boss tells me.
So 6%.
Questions about 36? 37 is in the wrong category. I'm not sure if I want to be that tricky for you or not. This isn't a percent change one. This is just what is 4% of 168, right? I don't even need to write. So that's bad. That should be up here in the percent of section.
Yep.
I can fix that when I get home. Questions on 37 other than why I put it in the wrong category? Which I don't know. Okay, you try 38 and I'll take attendance and then I'll quickly do another one. Okay, time for my test. So Elena is here. And I is here. Abellio. I should turn off my recording. You don't need to hear all of the names out.